Hey guys. All right. So you guys are moving forward in your little Unit 2 packets, and you guys are going to your paperclip lab, or it's called the Count by Wang lab. So let me pull mine out here. I added some notes on mine kind of as we go through this to include to kind of talk about some things, what I expect for you, kind of how to do the lab, set up the different problems with it, as well as then sort of the different things I need you guys to do with your little lab write-ups. So basically, paperclip lab, main thing you're going to need are paper clips, as well as those electric balances that are on the back counters. Okay. If you just turn them on and wait a little bit, it'll be kind of slow, but they'll eventually turn on. If you're having problems with it, just unplug it and then replug it back in, or you can zero it out a little bit. But otherwise, there should be three, I think I saw when I was up there this weekend. Somebody jacked my good one. Not sure who, but I will deal with that when I get to the school. Anyways, purpose. You are going to experimentally determine the number of paper clips in what we call a jack pound of paper clips. Jack pound's roughly 25-ish grams, but obviously it's not going to be a perfect 25 grams. Using this then, figure out how many paper clips are actually in that unknown sample there. Okay, so we just covered dimensional analysis a little bit. You guys have kind of done this in physical science where you're crossing out your units, going from one unit to something different. Using that information then, we're going to do a bunch of different conversions, basically to figure out how many total paper clips, average amount of them, are in what's called a jack pound. Safety, for obvious reasons. Please don't eat anything. All right, so let's get through it. We kind of have to set up our own little data table. That's kind of the first thing. And you're going to have different trials as you go through. So first, we have to figure out how many paper clips are going to be in a jack pound of paper clips. You guys are just going to use the paper clips that are on the chemical cart, and you're just going to take a handful of paper clips, stick them on the balance until you get somewhere around 25.000 grams. Sorry about that. Grams. Okay. If it's 25.001, wow, fantastic job. If you get like 25.8, 25.5 something, not a big deal. Okay. But you want to get somewhere really, really close to 25 grams. After you kind of set that up and you put those on the balance scale and you mass that out, say we've got trial number 1, number 2, number 3. Our mass, say our first one was like 25.015 grams. You're literally going to take them off the balance, count how many numbers of paper clips are in there. Then you're going to do it again a second time. Then you're going to do the same thing again a third time until we can come up with an average mass in grams as well as an average number of PC, stands for paper clips, you're going to have. You only have to do 3 trials. Never just do 1. Never just do 2. 3 at the most is really all you have to do though. Okay. But this is kind of what we want right here. Is we want an average mass, which should be close to that 25 grams, which is your jack pound of paper clips. Then you also have an average number of paper clips that could be in that jack pound, whether that's like 13 or if it's like in the 60s range kind of thing. Okay. So that's just kind of a lowdown of what you're doing all up until this point where you're repeating a third time. These 2 next steps, I kind of have asterisked a little bit because you are still doing some calculations with that. Okay. So then you're going to have to make a kind of separate data table there. If you want to try to include it on your other data table, I don't have a problem with it. But I personally am just going to create kind of a separate one. All right. So first we need to determine the average number of paper clips in your jack pound of paper clips, which we just did, as well as an average mass. I kind of have written over here. Sorry about that. We already went through that one. So I guess we're down to this one. Determine the average mass of one paper clip of a jack pound of paper clips. So in other words, you're going to take that number divided by the mass. Okay. Because you want to find really the average mass of just one paperclip, average mass of one PC. It's kind of what I have there for you. Okay, so we're going to use everything we just did up here to kind of create our different conversion factors. That's kind of the goal of this. So we've kind of created all these conversion factors. In other words, we have conversion factors of how many grams per jack pound of paper clips, we also have the knowledge of 1 Jack pound is equivalent to some number of paper clips. We're going to use these different conversions to kind of do the rest of this lab, which is the main purpose of this lab, to kind of go through this. All right, main portion here. Now you're going to obtain some different samples. So all of my different envelopes have a number on them. You got to make sure that you're going to record that number, because that's how I know if you kind of did this right or you did this wrong, as well as a container mass on there. Okay, so if we set this up, we're going to create a different data table where we're going to have, say, our number. It's going to literally be the number that is written on the side of the envelope. So let's say we're just number 1 right here. Then you're going to take the mass of your envelope, which obviously is going to be in grams. Notice these balances go out to the 0.001 decimal place. I want you to record that for every single one of your masses in this, though. Okay. Then literally write down the mass of the container or envelope. Write that down. That's the number I literally have written on that container for you. Then the mass of just the paper clips. Pretty sure you guys can figure out how to get that number right there. That's kind of the biggie one that you need, though. Okay, so you're going to do that with one envelope. Then you're going to grab a second random envelope and a third random envelope. You don't have to do numbers 1, 2, and 3. I don't care which numbers you do as long as you write them down. I think there's like a total of 20 or 15 to 20 different envelopes. Just make sure you write your sample mass, your mass numbers down. Wow, your envelope numbers down. Okay, so again, right here, that's kind of where I was correcting it. I know it says measured out to the 0.1 grams. I want you to go out all 3 of those decimal places. These balances are awesome. They can go out that far, so we're going to use that to our advantage. Okay, went through all that. Now we're down to sort of our calculations point. Number 1, we already did with that upper data table where you're doing your mass of the paper clips. Okay, determine the mass of just paper clips for each trial. Just did that. Number 2 and number 3 down here. Now we have to determine the number of Jack pounds in the sample and the number of paper clips in each sample. Okay, SF. You're going to see me write that a lot once I kind of get back there. Guess what that stands for? Sig figs. All right, so if your balances went out to the 0.001 decimal point, you're going to use that when you're doing your sig figs. Notice here I also show work. Okay, so showing your work, you're literally doing dimensional analysis. Okay, so like for number 2, you have to figure out how many Jack pounds are in each sample. Let's say, so this is like problem number 2. You're doing your trial number 1 up here, the envelope that's numbered number 1. You'll take the mass of your paper clips there, mass of PC, set up your conversion factor. Obviously, to cancel out the mass of the paper clips, you'll have to put that on the bottom. What do you want to go to? You want to go to Jack pounds. Well, do we have a conversion factor that goes between the mass of paper clips as well as Jack pounds? Yeah. We know from the directions at the beginning, or your purpose, that 1 Jack pound equals 25 grams. That's your conversion factor. But we're not going to use that exact 25 grams. Maybe you found an average mass somewhere sort of at the very beginning. Okay, so you know 1 Jack pound equals round 25 grams. You will put your average mass in there for you, though, equals blank. Therefore, you're going to get the number of Jack pounds in that sample number 1. Do that for every single one of your samples. Then number 3, you're actually going to look at the number of paper clips in that sample. Okay, so what do you have again? You have, say, in sample number 1, the mass of your paper clips. We have a conversion factor to go from mass of paper clips to Jack pounds. That's what we just did. 1 over around 25. Remember, you're not just going to do 25. You'll actually put your number there. Okay, now we also have another conversion factor. We know 1 Jack pound is so many numbers of paper clips. Again, something you found out in your averages at the very beginning. Do dimensional analysis, reach an answer for how many paper clips with every single one of your different trials there. Okay, number 4, number 5 are just some problems that you can work through as well. Dimensional analysis is key, basically to kind of get to those different points. All right, I'm going to post another video here that goes through your little write-up process though.